We are in the process of designing n-bit PCM system. So now you know how the quantization designing process. Now how the quantizer is designed for practical quantization error should be as minimum as possible. Okay, and you know what is n-bit A to D converter. What is the meaning of 2-bit A to D converter, 3-bit A to D converter? Okay, so the word PCM is nothing but the pulse codes. These pulse codes are varied according to this sample value. That's why the name is called as pulse code modulation. Okay, right? Now in the designing process, now see here, my question is, over a duration of TS seconds, how many samples are transmitted? One sample is transmitted. Over a duration of TS seconds, one sample is transmitted. Over a duration of TS seconds, one sample is transmitted, but each sample is encoded into how many bits? Each sample is encoded into 2 bits. Over a duration of TS seconds, one sample is transmitted, each sample is encoded into 2 bits. So, over a duration of TS seconds, 2 bits are transmitted. Now, over a duration of TS seconds, 2 bits are transmitted. Now, see here. Over a duration of TS seconds, 2 bits are transmitted. One is binary 1, another one is binary 0. Binary 1, binary 0. Over a duration of TS seconds, right? Now, over a duration of TS seconds, 2 bits are transmitted. Over a duration of TS seconds, 2 bits are transmitted. Then what is the duration of each bit? Each bit duration is represented as TB, which is equal to, over a duration of TS seconds 2 bits, each bit duration is nothing but TS by 2, right? Now what is 2 here? Because this is 2-bit PCM system, but what I am asking about n-bit PCM system. Now the next step is bit duration. Each bit duration is nothing but bit duration TB, which is equal to TS by, here is 2, but here it is n. Now this is bit duration. Now what is bit rate? Now the bit rate RB, which is equal to 1 by TB. The bit rate RB, which is equal to 1 by TB, which is equal to n by TS, which is equal to 1 by TS into n. Now this is nothing but sampling rate. This is nothing but sampling rate. Now this is n bits per sample, number of bits per sample. What is the sampling rate? Samples per second. What is the bit rate? Bits per sample. So this sample cancel, which is nothing but bits per second is the bit rate RB, which is equal to 1 by TB, which is equal to n by TS. Bits per second is the bit rate. No doubt. Okay. And the maximum bandwidth maximum bandwidth, which is equal to RB itself, which is equal to 1 by TB, which is equal to N by TS hertz. Why it is called as maximum bandwidth? Because with a minimum bit duration of, what is the minimum bit duration? The minimum bit duration of TB, if a minimum bit duration of TB, so what is the bandwidth? Inversely proportional to pulse width. Now 1 by TB minus 1 by TB. This is in time domain. This is in frequency domain. Now what is the bandwidth here? The bandwidth which is equal to 1 by TB minus 0, 1 by TB adjust. But if, see here, now this is 2 TB, TB, TB. Now with a bit duration of 2 TB, now this is a bit duration of 2 TB, then now pulse width is more, bandwidth is inversely proportional to pulse width. When pulse width is more, bandwidth is less. Now what is the bandwidth? Bandwidth which is equal to 1 by 2 TB. So pulse width is more, bandwidth is less. Now again 3 TB, bandwidth is less, 4 TB, bandwidth is less. In which case you can get the maximum bandwidth with a minimum bit duration of TB. So with a minimum bit duration of 2B, now this is maximum bandwidth. That's why you can write the maximum bandwidth is RB itself. 1 by TB means RB. Hold on. Okay. Now this is the way you can design a quantizer, and this is the PCM transmitter portion. Okay. So any digital technique you can take, which consisting of 3 common blocks: sampling, quantization, and coding. Now these are the procedure of that. Okay. Now this is PCM transmitter. Then you are completely aware of PCM transmitter. Now we'll see the PCM receiver. Nothing is there in the receiver. Exactly the reverse operation of transmitter is nothing but receiver. Now these are the binary data. Now this binary data is transmitting through the channel, and some noise is affected. That noise is eliminated by using a regenerative repeater. That we will study the regenerative repeater later. Then this binary data, which is the input to the decoder. What is the decoder? What is encoder? N bit A to D converter. So what is the decoder? N bit D to A converter. N bit D to A converter. Right? Now the decoder is N bit A to D converter. Encoder is N bit A to D converter. Decoder is N bit D to A converter. Now this is the original sample value, and this is the quantized sample value. This is the quantized. This is the quantized sample values. Okay. Now the output of the encoder is the binary data. Reverse is now this binary data is decoded. This is the quantized sample values. Now this is the binary data. Now this binary data decoded. Now this is nothing but quantized sample values. What is the meaning of quantized sample values? Now this is the quantized sample values. What is the quantized sample values? The quantized sample value is nothing but original sample value plus some quantization error. Is it right or not? So the quantized sample value, which is nothing but original sample value with some quantization error, but this quantization error should be as minimum as possible. So the original sample value is close to the quantized sample value. Sorry, the quantized sample value is very close to the original sample value. So now this is the sample value. Once the samples are available, already the sampling rate is oversampled. Once the samples are available, from the samples you can get back the original message signal. From the samples you can get back the original message signal by using a low pass filter, provided the sampling must be done with a rate of greater than 2 omega over sampling. If the signal is to be done over sample, then you can get the original information. Now this is nothing but the receiver portion. This is nothing but a PCM block diagram, transmitter and receiver. Okay, note down. Now see here. Now time division multiplexing by using PCM. Okay, now we'll see the time division multiplexing with the help of PCM. Okay, what is the time division multiplexing? Multiplexing, the transmission of more than one signal. Okay, a transmission of more than one signal through a single channel is called as multiplexing. If that multiplexing which is based on frequency, we call it as frequency division multiplexing, which we are already completed in the case of analog modulation technique. Now this is a multiplexing, but which is based on time slots allotted to each signal. So this is called as time division multiplexing. Okay, so but this is a digital communication. To convert any analog signal to digital, we need to process sampling, quantization, encoding. Whenever the sampling and quantization encoding comes into picture, now this is nothing but pulse code modulation. That's why I'm writing time division multiplexing with the help of PCM technique. Now similarly, see here. Now these are the three signals. This is the first signal. This is the second signal. And this is the third signal. Okay. Now these are the signals. First we are going for multiplexing. So these are the signals which we are going for multiplexing. Now these are the low pass filters which will allow a significant low frequencies and rejected all other unwanted frequency component. This low pass filters for the purpose of allowing significant low frequencies and band limiting the information signal and rejected the all other unwanted signals. Okay. Now see here. This is called as commutator. Is a switch. Now this switch is rotating from here to here, here to here. The time taken to complete one revolution of this commutator. The time taken to complete one revolution of the commutator is Ts seconds. Now, which is nothing but commutator speed. This is the time taken to complete one revolution of the commutator. Is called as commutator speed. The time taken to complete one revolution of the commutator. The time taken to complete one revolution of the commutator is Ts seconds. The time taken to complete one revolution of the commutator is Ts seconds, is a sampling time, sampling interval. Okay. Now what happening? Now the commutator switches at this one, at here. Now see. Now I will write here. Now this is the first message signal. This is the second message signal. And this is the third message signal. Now at t1 seconds, the commutator is collecting at t1 seconds. Now see here, at t1 seconds, first sample of first message signal. Okay. First sample of first message signal, or you can represent this one, xy sample signal. First sample of first message signal, first sample of second message signal, like that. Okay. So now this is at t1 seconds, commutator switches at this particular position. Okay. Now at t2 seconds, commutator switches at this particular position. At t2 seconds, commutator switches at this particular position. So at t2 seconds, commutator switches at this particular position, and it will collect first sample of second message signal. Now t3 seconds, commutator switches at this particular position. Now t3 seconds, first sample of third message signal. Now one revolution is completed. This is in the first revolution. And how much time it will take in the first revolution? Ts seconds. Okay. Now this is the way the commutator will collect the samples based on the corresponding time slots. At t1 seconds, first sample of the first message signal. At t2 seconds, second message signal. At t3 seconds, third message signal. Based on the time slot allotted for each signal, it will be captured. Now this is called as a time division multiplexing. This is called as a time division multiplexing. Now see here. Now Ts seconds is completed. Therefore, after t1 plus Ts seconds, now after t1 plus Ts seconds, now this is the second sample of the first message signal. Second sample of the first message signal, t1 plus Ts seconds. Now t2 plus Ts seconds. Now t2 plus Ts seconds, t2 plus Ts seconds, second sample of the second message signal. Now t3 plus Ts seconds, t3 plus Ts seconds, second sample of third message signal. Now this is the second revolution. Now first revolution Ts seconds is completed, second revolution Ts seconds completed. Now in the third revolution T1 plus 2 Ts seconds. So the time slot allotted for each signal, then within that particular time slot, then that first message signal samples are collected. Okay, so in this way all the samples are collected. Okay, first you just note down this. So now see here, this is one revolution, means how much time? Over a duration of ts seconds. Okay, right. Now this is the second revolution, third revolution, all these things. Now these are the sampled signals, am I not? Sampled values. Now this samples undergoes the process of quantization and undergoes the process of encoding. Okay. Now let us take this encoder is, if this is the encoder which is a 2-bit A to D converter, for example, let us say 2-bit A to D converter. If this encoder is a 2-bit A to D converter, now each sample is encoded into 2 bits. Each sample is encoded into 2 bits. Right? Each sample is encoded into 2 bits. Now my question is, right? Now see here, these are the bits 0 1 1 0 1, like now, and so on. Okay, and so on. Now you tell me, over a duration of ts seconds, how many bits are transmitted? 2 2 4 2 6, am I not? So the number of bits transmitted over a duration of ts seconds is called as frame. This is ts seconds, this is called as 1 frame. Now what is the frame duration? ts seconds. What is the frame? Number of bits transmitted, over a duration of ts seconds. The number of bits transmitted over a duration of ts seconds is called as frame. Frame length or frame duration is ts seconds. Okay, this is the ts seconds. Frame duration is ts seconds. So this is first frame, second frame, third frame, like this. The information is transmitted from one personal computer to another. Now information is transmitted from mobile to PC, PC to mobile, is transmitted from one PC to another PC in the form of frames, in the form of packets we are calling. That packets is nothing but in the form of frames. This is the frame, okay, over a duration of ts seconds, how many bits are transmitted. Okay, so now we'll find 3 things here. Now more than one signal is nothing but multiplexing, but that multiplexing is based on the time slot. The time slot is for first message signal is t1 seconds, the time slot for the second signal is t2, the time slot allotted for the third signal is t3, Now based on time, now these signals are multiplexing. This is called as time division multiplexing. Time division multiplexing. Actually, this is only time division multiplexing. I am using the word PCM because there is a sampling, quantization, encoding. Okay, this is the time division multiplexing. Now, again, same question I am asking now. First, we will finish the theoretical analysis. Now, over a duration of Ts seconds, how many samples are transmitted? Over a duration of Ts seconds, 3 samples are transmitted. 3 samples are transmitted. Over a duration of Ts seconds, 3 samples are transmitted. Each sample is encoded into, over a duration of Ts seconds, 3 samples are transmitted. Each sample is encoded into 2 bits. So, over a duration of Ts seconds, 3 samples, each sample is encoded into 2 bits. Therefore, over a duration of Ts seconds, total 6 bits are transmitted. 6 bits are transmitted. Over a duration of Ts seconds, 6 bits are transmitted. Then now you see here 6 bits, 0, 1, again 1, 0, 1, 1. Now see 0, 1, 1, 0, 1, 1. 6 bits are transmitted over a duration of Ts seconds. 6 bits are transmitted over a duration of Ts seconds. Then what is the duration of each bit is called as bit duration Tb. What is the duration of each bit is called as bit duration Tb. Now the bit duration Tb, which is equal to how much? Ts by 6. Now I am writing like this, Ts by 3 into 2, which is equal to Ts by capital M into small n. This is the bit duration. Now previously you can get only Ts by n, because in PCM only one signal, only one voice signal, but here there are 3 message signals. Therefore, this capital M is nothing but number of message signals. Number of message signals to be multiplexed. Total number of message signals. Now this small n is nothing but number of bits per sample. Number of bits per sample. Now this is number of bits per sample, and this is the total number of message signals to be multiplexed, and this is the number of bits per sample. Okay, now what is the bit rate? Now the bit rate Rb, which is equal to 1 by Tb, which is equal to 1 by Ts into capital M into small n bits per second. And the maximum bandwidth, which is equal to bit rate Rb. So this is the multiplexed signal, am I not? This is the multiplexed signal. Now the remaining thing is same. Now see here. This is the binary data. Now this is the decoder. Now n bit D to A converter. N bit D to A converter. Now the output of the decoder is a quantized sample value, right? The output of the decoder is a quantized sample value. What are the samples available here? M11, M12, M13, M21, M22, M23 and so on. These are the samples available. All samples are available here. Now all these samples are connected to the decode. What is here? The commutator which is used to collect the samples. Now this is the decoder. Decommutator. The time taken to complete one revolution of the decommutator is TS seconds. Now how the decommutator is working? Exactly the same as that of the commutator. The time taken to complete one revolution of the decommutator is TS seconds. Now at this particular interval of time, the first sample of the first message signal will be available here. Now the commutator switch is at this particular position. First sample of the second message signal. The commutator feed at this particular position. First sample of the third message signal. Now second sample of the first message signal, second sample of the second message signal and second sample of the third message signal. Like this. Third sample of first message signal, third sample of second message signal, third sample of third message signals. Now this is applied to a low pass filter. This is applied to a low pass filter because all these samples must and should be done with a sampling rate which is greater than the Nyquist rate, oversampling. So now that oversampled signals are reconstructed to the message signal by using low pass filter. This is a first message signal and this is the second message signal. Reconstruction is also based on different time slots. Now this is the third message signal, but the problem here is a synchronization should be properly done. If any mismatch between the speed of this commutator and the speed of the decommutator, then definitely it will get the wrong result. Okay. So now the disadvantage of this time division multiplexing is synchronization is must. Without synchronization you cannot do. Okay. Advantage means now you can have a more number of signals because a more number of signals based on the time slot. But in frequency division, one signal, one carrier, second signal, another carrier. But here, now one signal, just one time slot. Within 10 seconds, you can transmit n number of message signals because that 10 seconds is divided into different time slots. Okay, that is the advantages of this digital communication. Okay, now almost all the digital communication techniques, now definitely time division multiplexing is used. Okay, all mobile transmission or voice transmission in the mobile communication or wideband applications. Okay, now all wideband equipment are having a time division multiplexing technology and a PCM also. Okay, sampling, quantization, encoding. Okay. Okay, now see here. Frequency division multiplexing, time division multiplexing. Now what is the first point? Carrier comparison. Carrier frequency allotted to each signal. Now here time slots are allotted to each signal. All signals are transmitted through the channel at the same time. All signals are not transmitted through the channel at the same time. And the signals are transmitted in the allotted time slot only. Synchronization is not required. must and should require synchronization. Must and should requires the synchronization. Okay? No. Using time division multiplexing means over a duration of Ts seconds only n bits are transmitted. Now this is called as frame length. Over a duration of Ts seconds, how many bits are transmitted, that is called as frame length. Therefore here bitrate equal to bitrate, which is nothing but frame length multiplied with sampling rate. This is the general formula for bitrate. So in this example, bitrate RB, which is equal to frame length is n, sampling rate is 1 by Ts bits per second. Now here using PCM, not time division, but using PCM, no multiplexing, without multiplexing by using PCM. Now using time division multiplexing, over a duration of Ts seconds, how many bits are transmitted? Capital M into small n. This is frame length. Now the bitrate RB, which is equal to frame length is m into n into the sampling rate is 1 by Ts bits per second. Okay. Now using time division multiplexing with synchronization bits. Means now there is a mismatch of speed between the commutator and decommutator. Now if any speed mismatch between the commutator and decommutator are transmitter and receiver, we are adding some extra bits in the frame. Now this is the frame length. Now what is A? A is nothing but number of extra bits in the frame for synchronizing transmitter and receiver, or commutator and decommutator. Okay. So now the bitrate with synchronization bit is frame length is m into n plus a multiplied with the sampling rate is 1 by ts bits per second. So these are the number of bits in the frame. Parity bits, we call it as parity bits. Number of bits in the frame for synchronizing transmitter and receiver. Okay, note down.